Cams are frequently used in mechanisms to cause linear motion. In this video, we will investigate how to design and construct a cam in order to create the specific motion we want to create. The first step is to analyze the motion that you would like to create. Once you have identified the motion, you can represent it graphically. Suppose you want to replicate the motion of a horse rearing up onto its back legs as shown in the video. The horse's front hooves begin on the ground, then move up to the top of the motion. The horse remains in the upright position momentarily, and then the front hooves return to the ground. Which of these motion graphs do you think might be used to best represent the motion of the horse's head and chest? Perhaps the red motion graph better represents the motion of the horse's head and chest. It indicates that the horse moved up, then remained at the top of its motion for a time, and then fell back down to the ground. Notice that the horizontal axis of this motion graph is time. But if we wanted to create a cam to create this motion repetitively as we turned a crank, we could use the same graph shape, but use cam rotation as the independent variable. Once you have identified and graphically modeled the motion that you would like to replicate, how do you design a cam to imitate that motion in an automata? Let's look at an example motion graph. Can you think of any real phenomenon that might be represented by this motion graph? Perhaps this motion graph could represent the bobbing of a boat on gentle waves, or the rising and setting of the sun. This graph represents the motion resulting from a cam that was designed to replicate the motion displayed in that motion graph. Note that the shape of the graph is the same. However, the horizontal axis, x-axis, now represents the angle of rotation instead of time, and the vertical axis, y-axis, represents the radial dimension of the cam and includes a scale. Study the graph. What is the minimum radial dimension of the cam? The minimum radial dimension of the cam is 0.75 inches. What is the maximum radial dimension? The maximum radial dimension of the cam is 2.25 inches. What is the maximum displacement of the follower that will result if the cam is rotated about an axle? The maximum displacement will be 2.25 minus 0.75, or 1.5 inches.